It's Mark Summers from Summers Technical Services. We're going to finish up the last half of the video on the transient analysis for the flow over the cylinder and show you how to extract the data to correlate with your hand calculations for time and heat transfer coefficient. So here's a model with the results already completed. I'm going to right click. I just opened this up a minute ago, so I'm going to load the data, and it tells me that it's calling up the 2.fld file, which is the file that Solidworks uses to keep track of all the data points. And this is showing 600 seconds, so this is the end of the run. If you want to change the time you want to look at, you can right click and say load time moment, and I can load any time moment between 0 seconds and 600 seconds. And so you can only look at the time step at one time. So if I choose 300 seconds, I'm now looking at the data at 300 seconds. So let's change that back to 600. So to get these results, we're going to do two things. First thing we're going to do is surface parameters. So I'm going to right click and insert a surface parameter. First thing I need to do is select the surface I want to grab the temperatures from. So that's going to be that surface right there. I'm going to request the solid temperature, and I'm going to go down here, and for time history I'm going to select every 5 seconds. I don't want to show every 1 second because it'll take too long, and maybe I'll just show every, let's just show every 50 seconds or 60 seconds. We'll look at once a minute, twice a minute. There's 30, 60, 90, 120, 150. So had we only asked for the data every 5 seconds, this job here would have been a lot easier. So I'll go through 1, 210, 240. 70. Okay, and we have two options. We can say show or export to Excel. So right now I'm just going to say OK, and so that saved it as a new surface parameter right here. So I want to edit that again, right click, edit definition. Now I'm back in that same window with all my correct 30-second interval times. And down here I'm going to say show or export to Excel. So let's look at show. It's going to go through and calculate, pull that data. It doesn't calculate anything. It just pulls the data from the calculations already been done at each one of those time increments. And here I can look at any time I want, and it's giving me the maximum and minimum average temperatures of that surface. So at whatever time this is, 600 seconds, you can see it's already passed below 10 degrees. So if I hit this other button, time history, it gives me the whole time history, minimum, maximum, and average. And so looking at this, it starts off 30 seconds, it's gone from 23 to about 22. If I move to the right here, I can see that it looks like at about 510 to 540 seconds is where the temperature gets to 10 degrees. And so if I had closer, every 15 seconds, I could have resolved that better. So what you're going to want to do is find out when the model tells you it gets to 10 degrees, and you're going to check to see how that compares with your calculation you did with these equations, and hopefully those match up closely. The other way to do it is export to Excel, and it builds a gigantic spreadsheet that has all the points at every time step 30 seconds, 60 seconds, 90 seconds. It does all kinds of nice plots for you. Here's the time, here's the temperature. You can see where it crosses 10 degrees was just a little over 500 seconds. And so this is extremely useful to do your analysis, being able to extract that data this way. All right, so that was surface parameters. Now we're going to do point parameters. And so I'm going to right click on point parameters and say insert. And there's lots of ways to do this, but I want to do this XY coordinates. And so you're going to click on XY coordinates, and you're going to type in the XY coordinate. You want to extract the heat transfer coefficient, and then you're going to add those points. And I've made it somewhat easy to do that because I've got this spreadsheet called angles, and I want to type in the radius of my cylinder. It's a 58 millimeter radius, so I'm going to divide it by 2. And so here are the values of the points around the perimeter. So angle 0 is over here on the forward facing side, 180 degrees is over here, and so I've got numbers, coordinates for XY coordinates all the way from 0 to 360 degrees. All we're going to need to do is plot the first 180 because the bottom half is symmetric to the top half. And so I'm going to do a little quick screenshot here so I can get these numbers. I'm going to type in a couple of them to give you an idea how that works. And so minus 29 is 0, so I'm going to go back to Solidworks. So I want to type in minus 29 mm for X. I'm going to type in 0 for Y and 0 for Z. And I'm going to look on my model, and sure enough, if I look from the front, it's right on that front edge. And so once you type in the 3-point XYZ coordinates, you say add a point, and it adds it to the screen there. Now I want to go back to my screenshot here. I want to do negative 2856 and 504. So I'll go back up here and I'm going to say negative 28.56 mm. Converts it to meters. This is going to be 5.04 mm, and Z is still 0, and you can see it's right on the circle there at 10 degrees up. Add point. So you're going to do that over and over again until you get the points from 0 degrees all the way to 180. And so to speed this up, and excuse me, so once you get the points in there, you're going to come down here and say, what do you want to see? Well, I want to see, in this case, heat transfer coefficient. And then you go to time history and do the same kind of a thing. You decide what time steps you want to see, and then you can either show or export to Excel. And so since I only got 2 points here, I'm going to go to one I created earlier, this one right here. So I'm going to right click, edit definition on this one. And on this one, I've got all 0 to 180. I've typed all these points in manually. I've asked for the heat transfer coefficient right here. And for time history, I've asked for every 30 seconds, it looks like. So now if I say show, you're going to be able to see this is for 600 seconds. You can see my heat transfer coefficients are pretty constant, about 29 to 30. And so I can click this button here and look at the whole time history. And so for that point right there, you can see, if I click on different points, it changes the point. So for 0 degrees, heat transfer coefficient's about 39, stays pretty constant. If I go around here to higher angles, you can see how these change. And so what you're going to want to do is take the heat transfer coefficient, average them across all of those points, and then again compare that number to the H value you calculated using those hand calculations we talked in class. So those two things, doing the point parameters to get the H value, doing the surface parameters to get the surface temperature, time that it takes to go down to 10 degrees, correlate those to your hand calculations, and that's what I'm looking for project 2. So good luck with that. Stop by office hours and or our lab sessions during the week, and I can walk you through other questions you might have. So good luck.